So, you know that feeling like when you see a commercial for a brand new electric vehicle or one of those futuristic driverless robotaxis?
Oh, yeah. The ones where they're just gliding silently through some pristine, sunlit city.
Right, exactly. Like the passengers just chilling in the back seat, reading a book. The streets are completely empty, and the whole thing just looks, I mean, it looks completely effortless, like absolute magic.
Yeah, it really is a very carefully crafted illusion. No exhaust, no engine noise, just smooth, frictionless progress right into the future.
But then, you pull back the curtain, you look at what actually has to happen in the real world to keep those cars moving, and suddenly all that frictionless magic completely vanishes.
It vanishes
It
fast.
really does. So today we are stripping away the shiny marketing. We're doing a deep dive into a stack of internal documents, and this includes Electrify America's 2025 California Annual Report, actual unredacted crash data from the federal government regarding Tesla's robotaxis, and the financials of this robotics company that's trying to automate the whole charging process.
Yeah, we are really looking at the gritty reality of what it actually takes to keep this electric future moving. Our mission here is to help you understand what is really holding back the seamless, driverless ecosystem that, we've all been promised.
Right.
We're going to look at everything from the literal physical realities of the power grid all the way up to the software making life or death decisions out on the pavement. Because behind every shiny new EV is a remarkably complex and honestly often failing physical infrastructure.
So let's unpack this, because
hmm
before we can even talk about like putting robots behind the wheel,
Yeah.
we have to look at how human beings are currently dealing with the daily friction of EV charging. I was looking through this Electrify America report for California, and the scale they're aiming for is massive. But setting it up, it seems like a total nightmare.
Oh, it is a massive logistical undertaking. According to their data, they now have over 300 and 360 DC fast chargers in California alone. And just for context, a DC fast charger isn't like the plug you have in your garage that takes all night to fill your battery. These are serious industrial-grade machines. Electrify America is upgrading to these Generation AVs stations that can deliver 350 kilowatts of power.
Okay, wait, 350 kilowatts. What does that actually mean for, someone sitting in the driver's seat?
It means that if your car's battery architecture can handle it, you can add roughly 20 miles of driving range per minute.
Per minute? Oh,
Yeah, it is literally like trying to fill a swimming pool with a fire hose instead of your garden hose.
okay, so the tech is getting incredibly fast, and they're building these stations much bigger now, right? Like they aren't just dropping two chargers behind some dusty grocery store anymore.
Far from it. The strategy has completely shifted to creating massive hubs. So they are averaging 10 or more chargers per new location.
Right.
They just opened this massive 23 charger station at Fashion Valley in San Diego and an indoor 20 charger flagship hub on Harrison Street in San Francisco. The capital investment is just staggering.
But, and here's where the illusion of effortless progress just hits a brick wall. The friction isn't with the cars, right? It's in the ground and in the bureaucracy. Because the average time to just get a permit to build one of these fast charging stations in California is 117 days.
Which is already, 12% longer than the national average.
Right. But getting the permit is nothing compared to getting the power turned on. Getting the grid interconnection from the local utility companies, like literally just having them hook up the wires to a station that is already fully built, is taking an average of 101 weeks.
Almost 2 full years.
How is that even possible? Why does it take 2 years to literally flip a switch?
Oh, because it's never just flipping a switch.
Yeah.
When you drop 20 350 kilowatt chargers onto a city block, the local power grid just wasn't designed to handle that kind of load.
Oh, sure.
The local substations are aging. There is a massive global shortage of the physical transformers required to step down that high voltage power for consumer use. So you end up with fully built, multi-million-dollar charging stations just sitting behind chain link fences for 2 years, waiting for the utility company to basically upgrade the neighborhood's electrical backbone.
That is insane. So if you're Electrify America and you have, angry drivers wanting to charge their cars, how do you fight back against a 2-year grid delay?
You build your own grid, essentially.
Like, really?
Yeah, they are deploying what are called battery energy storage systems, or BES, at over 120 locations in California. They are literally putting massive industrial battery packs on site right next to the chargers.
Wait, so they're using batteries to charge batteries.
Exactly. It creates a virtual power plant. And this does two things. First, it helps bypass some of those grid limitations we talked about, but more importantly, it dodges demand charges.
Okay, hold on. What's a demand charge?
Yeah. So commercial power pricing is very different from your home electric bill. Utilities hit commercial properties with demand charges, which are these massive fees based on the absolute highest peak of power you draw at any given moment during the month.
Ah, okay.
So if four cars plug in at noon on a Tuesday and demand maximum power simultaneously, Electrify America's power bill for the whole month just skyrockets.
Right.
By having massive batteries on site, they can trickle charge those station batteries from the grid at night when power is cheap and plentiful.
Oh, that's smart.
Right. Then during the daytime rush, they just blast that stored power into the cars. It stabilizes the grid and slashes their operational costs.
Okay, that makes a lot of sense on a macro level. But, all of these grid constraints are still causing serious pain for the everyday driver. Let's talk about the congestion reduction effort in this report. At over 90 stations in California, Electrify America is now automatically cutting off a customer's charging session when their car hits an 85% state of charge. They are literally pulling the plug on you via software to force you to leave.
Yeah, it feels incredibly aggressive to the consumer, but it really comes down to the fundamental physics of lithium-ion batteries.
Well, explain the physics to me because,
Yeah.
as a driver, if I'm paying for a full tank, I want a full tank.
Okay, think of charging an EV battery, like packing a suitcase for a long trip. Throwing the first 85% of your clothes into the open suitcase takes just a few seconds. You just toss them in there.
Right.
But getting that last 15% in, you are meticulously folding, searching for empty pockets, trying to squeeze socks into corners without breaking the zipper.
It takes forever.
Exactly. As a battery fills up with the energy, the internal resistance increases. So, to prevent the battery from overheating and degrading, the charger's software has to drastically slow down the flow of electricity. That last 15% can take 2 to 3 times as long as the first 85%.
Wow.
So if a station lets a driver sit there for an hour just to get that last tiny trickle of power, the line of cars waiting to use that charger backs up right into the street.
It totally reminds me like a busy restaurant handing you the check right after you swallow the last bite of your main course. They just need to flip the table.
Yeah, exactly.
You haven't even looked at the dessert menu yet. It is incredibly annoying for the diner, but it's totally necessary to keep the restaurant in business. But let me push back here for a second. If they are building these massive 20-charger mega stations like the one in San Francisco, why do they still need to kick people off at 85%? Are these mega stations actually solving the problem, or are they just like Band-Aids for those 101-week grid delays?
Honestly, it's an uncomfortable truth for the industry right now. EV adoption in places like California is simply outpacing the speed at which utilities can lay down new high-capacity copper wire.
Jeez.
Those megastations are fantastic pieces of engineering, but if the local grid literally cannot handle all 20 chargers running at maximum capacity simultaneously, the software has to forcibly manage human behavior. Kicking humans off at 85% is really the only way to keep the line moving.
Okay, so a human driver gets a notification on their phone, they sigh, they unplug the cable, and they drive away. That works for now. But what happens when the car is completely empty? Literally, there is no human driver.
Right.
As these massive fleets of robotaxis and commercial electric delivery vans start scaling up, relying on a human to plug and unplug the cable suddenly becomes this massive, incredibly expensive bottleneck.
Yes, and this is a huge blind spot in the public perception of autonomous vehicles. We think about them driving themselves all day. But autonomy currently stops at the depot gate.
Wait, really?
Oh, yeah. Waymo is running hundreds of thousands of paid driverless rides right now, but at the end of every shift, those cars return to a massive parking lot where a crew of human workers has to walk around in the dark, manually wrestling heavy cables to plug them in.
Which brings us to the second source we are looking at today, which is Roxy's. They are a Dutch-American robotics company, and they just announced a $13 million Series A extension, which brings their total funding to $56 million. They've built something called the M1. What exactly is this?
So the M1 is essentially an overhead, rail-mounted robotic arm. It uses advanced computer vision and AI to completely automate the charging process. It detects an approaching vehicle, locates the charging port door, opens it, aligns the heavy plug, and locks it in.
That's wild.
And it does all of this with a 99.9% success rate, which is backed by 6 years of real-world operational data.
The overhead rail part is what really caught my attention, because if you have a massive fleet, buying one expensive stationary robot for every single parking spot would just bankrupt you.
Absolutely.
But this M1 robot slides along an overhead track, meaning one robot arm can service up to 10 different parking bays.
Yeah, that multi-bay architecture is really what changes the financial equation.
It's like having an automated bartender sliding up and down a long bar, right? It serves a drink of electricity to the car in bay 1, slides over to bay 2, serves that car, and just keeps the whole bar running all night. You don't need to hire 10 different bartenders.
That's a great way to put it. And Roxy's has the math to back that up.
Yeah.
They estimate that for a 50-bay commercial charging depot, removing the need for 3 shifts of human workers managing those cables results in a 75% jump in operational efficiency.
75%.
Yeah. That translates to about $1.7 million in annual savings.
But this isn't just for little robotaxis, right? Because
Mhm.
I see in the announcement that Scania just invested in this round. And Scania manufactures those massive Class 8 semi-trucks like the 18-wheelers hauling heavy freight across the country.
Exactly. And the heavy freight application might actually be more critical than the robotaxis because the cables required to charge a massive Class 8 semi-truck at megawatt speeds are not like the ones you use for a passenger car.
Right.
They are incredibly thick, heavy, and physically liquid-cooled to keep from melting. They are genuinely difficult for a human being to wrestle with, especially in the rain or snow, multiple times a day. A robotic arm doesn't pull a muscle in its lower back, you know?
Yeah, that's a fair point. Okay, I have a major question about this approach, though. Tesla just showed off their purpose-built Cybercab, and the big selling point was that it uses wireless inductive charging. Like, the idea is that the robotaxi just parks over a charging pad buried in the pavement, and it charges wirelessly. No cables, no robot arms.
Right.
So if you can just park over a pad, why does Roxy's and their complicated robotic arm even matter?
It comes down to interoperability and the reality of the legacy fleet. Tesla's Cybercab is a concept built from the ground up to be wireless. But what about the millions of EVs that are already on the road today? What about Waymo's massive existing fleet of Jaguar I-Pace SUVs?
No.
Yeah. You cannot easily or cheaply rip apart thousands of existing vehicles to retrofit them with wireless inductive receivers.
Ah, I see.
Roxy's robotic arm is agnostic. It works with the existing standardized ports that are already built into the cars on the road today. It basically saves a fleet operator from having to completely scrap or rebuild their current vehicles just to automate their depot.
Okay, that is a crucial distinction. So robotic arms can solve the charging bottleneck in the safety of a closed depot. But the second those driverless cars leave the depot and hit the open highway, a totally different bottleneck emerges. So let's look at the actual rollout of these robotaxis on the street.
Yeah, this is where the ambition of the tech companies really collides with the hard reality of public safety.
Let's look at Tesla's numbers. They're planning a wildly aggressive expansion in the first half of this year. They're trying to launch their robotaxi service in Dallas, Houston, Phoenix, Miami, Orlando, Tampa, and Las Vegas.
Ambitious.
Very. And their corporate data claims they've already logged 700,000 paid miles in Austin and the Bay Area. On paper, it sounds like total domination.
But when you look at independent investigations into how those 700,000 miles were actually driven, a very different picture emerges.
Right, so Reuters sent reporters to test the service in Texas, and they uncovered what they politely refer to as severe convenience issues. Like in Dallas, a reporter tried to take a 20-minute, 5-mile trip downtown. It took nearly 2 hours to complete.
2 hours.
2 hours. The app showed massive wait times. The car absolutely refused to get onto the highway. It was taking these bizarre, meandering surface streets instead, and it ultimately dropped the reporter off in a random parking lot, a 15-minute walk away from their actual destination.
And, you know, the situation in Austin where the service has supposedly been operating for a year wasn't much better.
No, not at all. A local reporter checked the app consistently for weeks. Half the time they opened it, the wait time was over 15 minutes. And 27% of the time, there were simply 0 cars available to book. And local city officials revealed why. There were only about 50 Tesla robotaxis operating in the entire city of Austin.
50.
Yeah. Compare that to Waymo, which has over 250 cars operating in the exact same city. So why the massive discrepancy? If Tesla wants to be in 7 new cities, why do they only have 50 cars in their hometown?
Well, the answer is buried in a recent earnings call. Elon Musk admitted that safety validation is the primary limiting factor for their fleet size.
Which brings us to the National Highway Traffic Safety Administration, the NHTSA, the federal crash data. What does it actually say?
So since launching the service in Austin, Tesla has been forced to report 15 crashes to the NHTSA. If you run the math on their 700,000 claimed miles, that equals one crash for every 57,000 miles driven.
Okay, 57,000 miles sounds like a lot to a regular person. Is that bad?
It is deeply problematic when you compare it to a human. The national average for human drivers is roughly one crash every 229,000 miles.
Oh, wow.
Yeah. So based on the current data, Tesla's robotaxi crash rate in Austin is about 4 times worse than the average human driver.
Let me wrap my head around that. They only have 50 cars in Austin. The Houston service area is restricted to a tiny suburban pocket. In Dallas, the software physically refuses to merge onto the highway. Are these convenience issues, like the long waits, the bizarre routing, the random drop-offs, are they actually just a safety net in disguise? Like, are they keeping the fleet artificially tiny and restricting where it can go just so the total volume of crashes doesn't spike and make national headlines?
Honestly, that is the logical conclusion of the data. If your system has a crash rate of 1 in 57,000 miles, you physically cannot scale to 10,000 cars driving all day every day in complex urban environments. It is a mathematical certainty that you would be generating severe headline-grabbing accidents on a daily basis.
Right.
So the convenience issues aren't glitches in the booking app. They are the physical manifestation of the AI's safety limits. The vision-only AI system simply isn't confident enough to handle the high speeds, split-second decisions, and complex merges of a Texas highway. So the software just forces the cars onto slower surface streets and quiet suburbs to mitigate the risk.
Wow. Okay, so the safety math is keeping the AI on a very short leash. But we know these cars aren't entirely alone out there right there. When the AI gets confused, what happens? Because the newly unredacted NHTSA reports finally give us a look at what happens when the safety net itself fails.
Yes. So Tesla was forced by regulators to unredact the details of the 17 total incidents in Austin. And it brings us to a fascinating and highly vulnerable part of the ecosystem, which is the teleoperator.
Yeah, because most of the incidents were relatively minor. Clipping a side mirror, hitting a metal chain stretched across a parking lot. At one point, dog darted out into the street, but thankfully the car stopped and the dog was unharmed. But 2 of these specific crashes involved these human teleoperators. What exactly is a teleoperator?
A teleoperator is a remote human worker sitting in a control center, often miles away from the vehicle. When the autonomous AI encounters a construction zone or, like, an edge case it just doesn't understand, it stops the car and pings the control center. The teleoperator then takes over the steering wheel remotely to navigate the car out of the jam. But legally, and for safety reasons, they are only authorized to drive the car at speeds under 10 miles per hour.
So they are like a remote lifeguard for the AI? But the unredacted reports show that the lifeguards are crashing too. In July 2025, a teleoperator took over a stuck robotaxi, accelerated, mounted a curb, and smashed right into a metal fence. Then in January 2026, another teleoperator took over to navigate a car around a street barricade and drove right into the barricade at 9 miles per hour. Thankfully, there were no passengers in the vehicles during either of these crashes, but it raises a huge red flag.
It really does. It highlights one of the most critical yet under-discussed vulnerabilities in the entire autonomous vehicle industry, which is the handoff.
It totally reminds me of playing a fast-paced racing video game online, but you're on a terrible, laggy Wi-Fi connection. You see the wall coming on your screen, you turn the controller to avoid it, but the video feed stutters, the signal lags, and your car smashes into the wall anyway. The human is desperately trying to help the AI out of a jam, but the technological disconnect between the remote driver and the physical car causes an accident regardless.
That is a perfect analogy for the engineering challenge here, because when a human teleoperator takes over, they are driving purely based on two-dimensional camera feeds streaming over cellular networks. They completely lack the biological tools we use to drive safely.
Right.
They have no inner ear equilibrium to feel the car tilting on a curb. They have no physical sensation of momentum. They have zero peripheral spatial awareness.
You don't realize how much you're driving is literally feeling the road until you can't feel it.
Precisely. And when you add in even a few milliseconds of cellular network latency, that video game lag you mentioned, trying to navigate a 2-ton vehicle through a tight construction zone, even at 9 miles per hour, becomes incredibly dangerous. It proves that companies can't just slap a remote control steering wheel onto a robotaxi and consider all the edge cases solved. The handoff itself is a hazard.
So we have covered a massive amount of ground today. We started at the literal plug, looking at the physical limits of our power grid, where aging substations and transformer shortages are causing 101-week utility delays. And that friction is forcing companies like Electrify America to actively kick human drivers off their chargers at 85% just to keep the ecosystem from collapsing.
We then looked at how robotics companies like Roxy's are stepping in to completely automate massive charging depots, using multi-bay robotic arms to keep autonomous fleets moving without the physical limitations of human workers.
And finally, we brought those cars out of the depot and onto the street. We saw that the frustrating 2-hour wait times and bizarre routing that robotaxi passengers are experiencing aren't just bad customer service, they are the direct result of a system struggling with safety validation. The AI isn't ready for the highway, the crash rate remains significantly higher than that of human drivers, and the remote human teleoperators are struggling to bridge the gap.
It really forces you to view those pristine, frictionless commercials in a completely different light. The vehicles are advancing rapidly, but the physical world they have to operate in is pushing back hard.
So we want to leave you with a scenario to ponder today, something that extends beyond the reports we've covered. Think about your own daily routine and your own home. As these massive, fully automated fleets continue to scale up, thousands of robotaxis that can drive themselves and plug themselves in, they're going to start drawing unimaginable amounts of power from the grid. What happens when the infrastructure gets so smart and so constrained that it starts making decisions against you?
Oh, man.
Imagine a massive automated robotaxi depot down the street from your house. They need to charge 500 cars for the morning rush, and their algorithm is willing to pay premium surge pricing to the utility company to get that electricity. Does the local power grid decide to throttle the power to your personal EV plugged into your driveway as a result? The cars are getting smarter, and they are learning to drive themselves, but the battle for the infrastructure that actually powers them, that is just beginning.